Hello, today's lesson is on graph transformation with the aim of knowing how to apply all types of transformations to graphs and curves, recognise transformations and be able to apply transformations to coordinates. I hope it helps you and enjoy. So we're going to start off with what the types of graph transformations are. Okay, we have translations, so you can move things up or down, left or right, which does not change the size or shape of the graph. We have reflections in either the y-axis or the x-axis, and we have stretches, horizontal and vertical stretches, which is probably the one that you're not so familiar with. You will have done translations and reflections and rotations and enlargements before, but stretches is a new one that's specifically used to get your higher grade at GCSE. And just so we know, so what I'm going to be referring to in this PowerPoint, any graph I refer to as a function. This means that I can draw random graphs and just say the function, and then we know exactly what to do for that. Okay? And we use the function notation. Fx means the function of x, and that could be anything from a quadratic to a cubic to a sine or cosine rule, sine cosine curve, whatever it might be. Okay? So we're going to start off with vertical translations. So you see at the top here in this blue box, we've got f of x, which is the function of the graph, plus or minus a, and a is going to be a number. Okay? And what this does is it tells us how to move a graph vertically. So if I was to draw the graph, f of x is x squared, this means that I'm drawing the x squared curve, which we should know looks like this. Okay? Now, if the question or a question asks you to sketch the curve f of x plus 2, this means that the graph has moved up 2 spaces. So the plus 2 has made me move the graph, move up the y-axis 2 spaces. The shape of the graph hasn't changed, but the minimum point has gone from 0 to 2. So it's just been shifted up 2 spaces. If I were to sketch f of x minus 4, it would look like this. So going from the black one down to the red one, I've moved it down 4 spaces. The minus 4 has told me to do so, and I've just moved it and sketched it. So a positive a value, a positive number, means you move up, and a negative number means that you move down. So quite straightforward at the moment. Slightly different if your number is inside the bracket. So if we go back before, we had f of x plus or minus another number. This time we've got f brackets x plus or minus a number inside the function. So it changes it slightly to horizontal translations. So again, we're going to use f of x is x squared as our main graph to move. And if I was to sketch f of x plus 2, it's going to go like this. Now you would think that because it's plus 2, it would move to the right. But it is the opposite way to what you think. It's actually moving it to the left. So a plus 2 or positive number means the graph moves to the left. And if you have a negative number, so minus 4, means we're actually moving it 4 spaces right. So it ends up being there. So you need to remember, if something's inside the bracket, it's the opposite to what you think it would normally be, which is weird, but it does kind of make sense. When you see more, you'll realise what I mean by that. Great. So here's another one. We're going to have a go. Feel free to pause the video if you want to try them on your own first, and then I'll go through it. So this time I've just got a function. I have no idea what this function is called, but we know it's f of x, so I can now move it around and put it in the place it's meant to be. So the first one is f of x take away 3. Now because the number is on the outside, that means I'm moving this 3 spaces down. So I would literally draw exactly the same thing, 3 spaces down, sketch it as best I can, and there we go. Notice how the main thing that I've done is make sure that my y-axis is at minus 3, and if you have other places that chop the axes, make sure you do that as well, just make it really accurate. So the second one, this time the minus 5 is inside the bracket, which means I'm doing the opposite to what I think I'm doing, so I'm actually moving it 5 right, like this. So again, make sure you cross at the right points on your axes. I've gone from 0 to 5, and I've also made sure that I've gone from my minus 3, 5 spaces up to 2. So I've sketched it as accurate as possible. If I move on to C, I've got my 4 inside my bracket, because it's inside, I'm actually moving it 4 spaces left. It's opposite to what I think. Okay, so I'm going to move 4 spaces left, sketch my graph, and there we go. And D, we've got f of x with a +2 outside of the function, which I'm moving it 2 spaces up. So I'm going to move 2 spaces up like that, and there we go. So why don't you have a go yourself? Pause the video, copy the graphs, and you'll see at the top ABC all of the functions that I'd like you to have a go at. So pause the video and see how you get on. And these are your answers for those questions. So I've done A, B, and C in different colours so you can see if yours were in the right place. So we're now going to be on to our next lot of graph transformations, which is reflections. Now, you know how to reflect a shape. You normally have to reflect shapes in lines, but this one will only link with the reflection in the x-axis and reflection in the y-axis. So we're going to start off with this one, minus f of x, so minus the function. This means we reflect it in the x-axis. So if I was to reflect this x squared curve in the x-axis, it reflects down below, like that. If you have f with a minus in front of your function in the bracket, that means you're actually doing it in the y-axis. So actually, if I was to draw a reflection of the x squared curve in the y-axis, it's exactly the same, isn't it? It's the same on the left, same on the right, so it's not really anything you can really see. That's why I've gone over it in red. So let's have a go with a different kind of shaped function. So the first one, we've got minus f of x. The minus is in front, which means that we are reflecting in the x-axis. So this would end up being flipped over like that, kind of upside down. Makes a weird shape, but that will get us the mark. The second one, f of minus x, it's inside the bracket, which means that we're reflecting it in the y-axis. So if I was to twist it over in the y-axis, it looks very similar to our last one, doesn't it? But that's what it would look like. And then C is a combination of not just a reflection, but a reflection and then a translation, because we've got the +3 at the side. So this one, I'm going to reflect it in the x-axis first, because the minus is outside the function, and then move it up 3. So I'm going to reflect and move up. You could do this in 2 stages if you wanted to, but I was being lazy and just wanted to do it in one go. So I've reflected it, so it's flipped upside down, and then I've moved it 3 spaces up. So have a go at these questions here, draw them, make sure you can do your reflections, and see how you get on. Now, unfortunately, I don't have the answers for the reflection ones for some reason. So we're going to move straight on to our final one, which is stretches. Now, this is the one most people struggle with because it's new and it's slightly different. But if you follow kind of the rules for it, you should be able to give it a good try. So we're going to start with this, a f of x. A is just, it can be any number, and we're going to see what happens when we do it to a function, okay? So just to let you know, the number in front of the function changes in the y direction, changes the shape of the coordinates, so a vertical stretch, okay? So f of x is here. Now if I was stretching it vertically, it means that it's going to get kind of longer and thinner, okay? So 2f of x is going to end up being like this, all right? And if I look at my coordinates here, if I look at the one on the y-axis, I've got 0, minus 1. Because it's 2fx, I've then changed it to 0, minus 2. So it's been stretched in the y direction. My x-axis coordinates have not changed. They still cross the x-axis at the same point, but the graph is stretched to go down a bit longer and a bit thinner, okay? And the y coordinates have basically doubled. So the number in front is telling you to double your y coordinate. 3fx is going to look like this. And again, your x's haven't changed, but your y coordinates have been times by 3 to make it 3 spaces lower down. So it's tripled. And you can see it's a longer, more thinner curve. The x coordinates haven't changed, we've already said that. So hopefully you get the idea of what that does. Look at the coordinates, 4, 6, 4, 4, 4, 2, only the y coordinate is changing. So now we're going to look at slightly different stretches. We're going to look at when we've got a number inside the bracket next to the x. So instead of stretching vertically, we're going to be stretching horizontally this time and changing the x direction and the x coordinates, okay? And again, because this is inside the bracket, this is the opposite to what you think is going to happen, okay? So we're going to look at f of x here like this. F of 2x, you would think that it's going to stretch twice as big in the x direction. But actually what it does is it stretches inwards. The 2 means we're actually dividing the x coordinates by 2. And if you had a 3, it means rather than times it by 3, you're actually dividing your x coordinates by 3 to make it go inward. Okay? If you actually look at where the coordinates are here, for example, take the black edge, we've got 6, 4. If I was then doing 2f of x, I've got 3, 4. So I've halved my x coordinate, and then obviously divided by 3 to get the top of the red one, 2, 4. Here's another example. Here's my function, f of a half x. Now, because remember we're doing the opposite to what we think is going to happen, we're actually not halving here, we're actually doubling, like this. And if we had a third of x, we're not a thirding it, we are timesing it by 3. So it's actually stretching it wider. So again, it's the opposite to what you think. Okay? And if you look at the coordinates, we've got 6, 0, 4, 0, 2, 0. The y coordinate has not changed, but the x coordinate is what's been changed every single time. And it might be that the minimum point sometimes changes too, depending on the type of graph. So, pause the video, have a go at these, sketch these curves out, and see if you can answer the questions. And there's also 5 to 8 on the next slide. So when you finish these, move on to the next slide. Here's your next questions. Pause the video. These are the answers for question 1 to 4. And these are the answers for question 5 to 8. Hopefully you did all right on those. And here's our next bit. So now, to get those even harder questions correct on your GCSE exam, you need to be able to apply the stretches, the reflections, I can't remember the other one, but stretches, reflections, and translations, but to trig functions. So, first of all, f of x can be, obviously on here, it's going to be sine x, because you can see on the question, you've got minus sine x, sine minus x, and 2 sine x. So obviously I need to draw the base one first, okay? Now, minus sine x, if we look back at our notes, what we've made so far, the minus means that we are reflecting this in the x-axis. So I'm just going to flip it over like that, and that would be my answer for the first one. For B, I've got a negative inside my bracket, which means that we are reflecting in the y-axis. So after reflect it in the y-axis, it would look very similar, but we would still be able to do that. And on C, we have our 2 in front of the function, which means it's going to be a stretch, but we're doing a vertical stretch, which means that the y coordinate is going to double. So if I was to draw that out, look at all my y coordinates, they've doubled, but my x coordinates have stayed the same. It's still crossing at 360, minus 360, minus 180, 0, 180, and 360. If we have a go with these ones, we've still got our sine x function, sine 2x. Remember, the 2 is inside the bracket, so it's the opposite to what you think. So we're actually halving the x coordinate. So it's going to look looking like this, which looks a bit weird, but because it's halving, it's going to repeat itself more, okay? And it's still going up to the same height, it's still going up to 1 and minus 1, but it's obviously being repeated more often. And for B, we've got sine a half x, because it's the opposite to what we think. We're actually doubling the x coordinate this time, which means it's going to be, I've had to go over the edge, but it's so stretchy, it's really wide and long. So while you have a quick go at these, this is kind of looking at going from blue graph to red, what have you actually done? So pause the video and see if you can have a go at that. And these are the answers. So the first one is f of x minus 2, because it's been moved horizontally. This one is f of x plus 2, because it's been moved vertically to upwards. This one is actually a stretch. As you can see, it's gone stretching horizontally. And remember, because it's 2, we've had to divide it by 2. And the last one, a little bit trickier, f of a half x plus 1. So I've done a stretch and a translation in that. And here are some more GCSE questions in that kind of style. Pause the video, have a go at these, draw the graph first, and sketch on the functions. Here's another one for you to try. See how you get on. Okay, so here's another little point that we need to be able to know about, and basically something called oscillation. Basically, oscillation means that this graph is repeating itself and it's moving back and forth in the same kind of pattern. It's always repeated. So if you've got a section of it, you know that section is repeated on the next bit and the next bit and so on. So as you can see here, between 0 and 360, this whole curved part, so the kind of the mountain and the valley, is classed as one oscillation before it then repeats itself. Okay, so you can see the 0 and 360 is the one part of doing it. So it's a little side thing, just make sure we know that in case it. So now we're going to move on to finding coordinates and missing values. So this is the kind of question that does tend to come at the end of the paper. So they've given me a graph, and the question says the graph shows the line with the equation y equals sine bracket ax plus b. Determine the constants a and b. Now this means I need to tell them what a and b is as a number. Okay, and to help me with this, I would draw a quick sketch of the normal sine curve and then begin to see how the normal sine curve differs to the current one that they've given me in the question. So I know, just from doing my transformations, that if I've got an a inside the function bracket, I know it has to be a stretch. And if I look at my stretches, I can see that it oscillates twice as much as normal, and the x coordinates have actually halved. Okay, so if an x coordinate is halved and it's in the bracket, that means that my a value has to be 2, because remember it's the opposite to what you think. I also know that I've got a plus b, which for me, I know that that is a translation upwards. Okay, we know it's gone up, it's gone from 1 up to 2, so obviously we're going to have our 1 because it's been moved up 1 position. So for my final answer here is I figured out that a has to be 2, I figured out that b is 1, so this would be my final answer that I'd write down. Sine 2x plus 1, which symbolises a horizontal stretch and a translation of 1 up. Here's another one. So I've got y equals a sine bx plus c, determine the constants a, b and c. So it's a sine again, so there's a sine curve to kind of help me. And just to kind of break it down again, okay, I know that a is a vertical stretch because it's in front of the function, b is a horizontal stretch because it's inside the function, and c is a translation, okay? And I've put down on here because obviously look at where the graph is crossing, the y-axis is crossing at -1, whereas normally that would be crossing at 0. So we know it's going to be moving down at some point. So straight away I can figure out what my c is, okay? So if I look at all of it, I've gone straight to the answer here, all right? But you'll be able to see that the 2 is obviously your stretch vertically in front. Your 4 means that your x coordinates have been divided by 4, which is why it's oscillating so much. And the -1 means it's all been shifted down space. There we go, 2, 4, -1. So here are some other kind of styles of questions that you might see on the GCSE. So we've got a question here, we've got y equals fx, we've got a coordinate that's at the maximum point, and the question says the diagram shows part of the curve with the equation y equals f of x. The coordinates of the maximum point of this curve are 2, 3. Write down the coordinates of the maximum point of the curve with the equation f of x plus 2. So what I need to do on this is go, right, well I know that if it's inside the bracket, that means I'm moving my function 2 spaces to the left. So if I was to move that coordinate 2, 3, 2 spaces to the left, what would my coordinate be? I'd only need to change my x coordinate, so it'd be 0, 3, because I'm moving it 2 spaces left, which means I'm going 1, 3, and then 0, 3. So I get a mark for that. If it was b, 2 of f of x, I know that the 2 in front of the function means that it's a vertical stretch, which means that my y coordinate is changing and it's doubling. So all I need to do with my y coordinate is look at it and double it and write it as 2, 6, because 3 doubled is 6. And that will get me 2 extra marks. Have a go yourself and see how you get on. And that is the end of our PowerPoint. I hope you've enjoyed it. I hope you've learned something new. I hope it's given you a bit more confidence with your graph transformations and also applying it to trigonometry as well. Bye.